Dear student, today I am giving lecture 4 based on the wave equation to solve for step index fiber. To solve this wave equation for step index fiber, we will use the Maxwell equation. Previously, we have solved for this step index and gradient index fiber for ray optics theory. In this, we will consider the electromagnetic theory in order to evaluating the uh, wave equation propagating in the z direction, and wave equation is taken in term of both E and H mode, and accordingly we can find the transverse mode for this step index fiber. So for that, first of all, we have a some sort of a condition in order to giving this wave model or to find the solution for step index fiber. We assume that for this model, ray theory explains the thing quantitatively and perhaps not conclusively. And ray theory does not predict about the evanescent field after the total internal reflection in the fiber. There is no idea about this evanescent field which is to be propagated, whether there is some leakage that has to be occur in the cladding part. That is not we have explained in the ray optics theory, and ray theory does not give the accurate behavior of the light in the fiber. It just gave an idea about the ray that is propagated in the core as well as in the cladding. It is treat light as an electromagnetic signal, so E and H both are propagated perpendicular to the each other in the direction of propagation, and we assume that in the optical fiber the direction of propagation is in the z direction, and that is same as to the core or axis of the fiber. So Maxwell equation has to be represented for analyzing of light signal, as a fiber is to be considered as a cylindrical waveguide. For the cylindrical coordinate system, we consider this r, phi, and z is the direction. These three coordinate system is to be taken is the this diameter of the fiber, n is the refractive index of this core, and n2 is the refractive index outside this core. So r, that is when it is greater than that of a, then this n2 is the refractive index that has to be considered for our assumption. So as per Maxwell's equation for EM wave in optical media, that give the relationship about both electric and magnetic field, and assuming a linear isotropic dielectric material having a no current and no free charge, and for that del dot d is equal to 0, although this d that is represent a basically a like this is epsilon e, this means e is equal to 0, and another is del dot d is also equal to 0. This b is equal to mu h, this means del dot h is also equal to 0. So another is the cross product of this del cross e is equal to minus dv upon dt, and del cross h is also equal to minus of this d d upon dt, and the charge density and conduction current density here in the media that has a 0 which we have already considered, and there is a no current and free charge which we have considered. uh, the epsilon is the permittivity of this dielectric medium or dielectric constant, and mu is the permeability of this medium. So further relationship, by taking the curl of this del cross third equation, whenever we take the curl, and that is equal to del cross dB upon dt, and the value of B is equal to mu h, we have to apply it here, and that is become del cross h. So del is directly linked with this, and mu is taken outside, and this del cross E is equal to basically a formula from the electromagnetic theory, which is a merge out is equal to del dot E plus del square E. So this del dot E is equal to 0, which we have already elaborated in equation 1, and same is elaborated in equation 2 if there is a del dot H. So putting this value, we got only this del square E, and here del cross H, which we have taken, this del cross H is equal to minus d upon dt. So whenever we apply this minus, minus sign is cancelled out, and the value of this d is equal to epsilon E is to be filled, and epsilon of this and mu of this, that is taken out, and whenever we put this del cross E, there is a d upon dt, and this d upon dt, that is becomes the square. So d is equal to, we have already mentioned epsilon E, epsilon is taken out, E is, so del whenever take there is a E value is directly came here. So fourth equation we have obtained. Similar why same, if we have to taking the curl of fourth equation and solving in the same manner, then we will obtain this expression, which is equal to a del square H equal to minus mu epsilon d square H upon dt square. So we obtain these two questions are obtained. This question fourth and fifth is basically known as a wave equation, which is used for solving the step index fiber. So next is that we have taken a cylinder with R, phi, Z. The fiber is considered as a cylindrical fiber with the R, phi, Z. These are the coordinate of this, and propagating in the Z direction. So EM wave is basically propagating in the Z direction. Then the field E is to be taken as E naught is the maximum amplitude, which is the function of both R and phi, and this is the propagation part. E raised power j omega, j is common omega t minus beta z. So that is obtained. Now in order to solve further, we have to differentiate this equation with respect to direction of propagation. When we take differentiation of this, the component of this E is obtained same, and the component of J beta is come, and this part is become 0, and negative sign is to be merged out. If we see, this part is same as that of the EM wave propagating in 0, then this part we represent only in a E vector minus J beta E vector, that is the d upon dz, or we can say d upon dz is equal to minus J beta. Similar, we can we have a magnetic part, magnetic field with the maximum magnetic H naught R phi e ray power j omega t. That value we can also find. Now we have a standard Maxwell equation third, which is equal to a del cross E equal to this minus dB upon dt, and this value is equal to mu is to be taken, and the value of h we have taken the value of that is in the previous slide. uh, the same we have to use, and when we fill it here, and uh, it is taken the derivative with respect to t. So mu is already taken out. Whenever we take derivative, negative sign, j omega is to be emerged out from that. J omega mu h is again the part. So this will be the final equation for del cross E is equal to minus j omega mu h. Now, as we know that this uh, del cross E is equal to a taking the coordinate system, like there is a r phi z with 1 upon r, that has to be the function of z, and r is also the function of this vector r is also 1 upon r. Then d upon dr, d upon d phi, d upon dz, and the field in er, field in this direction there is a r e phi and ez. This is the field. Now we have just open it out by taking this as a r, say vector we have taken common. Then this d upon d phi into ez multiply by 1 upon r minus d upon dz into e phi. R which is to be taken at here is cross out with this 1 upon r, so this r is not at here. Then at here we taken the minus sign is basically goes inside, so here we have taken the plus. Otherwise this is 5, we have to cancel this side. D upon dr into ez, that is negative sign, and another is positive with d upon dz into dr, d upon dz into er, that is the second, which is the positive sign. So 5 is the common vector for this. Now third we have 1 upon r with z vector. So this and this will be reach, and we just multiply this minus multiply by this. So d upon dr into then this d upon dr into r e phi minus d upon d phi into er, z is the common, and on the right side minus j omega mu h is to be taken. So this value is obtained. After that the value of e phi which we have taken, that value we have from the previous question, that is e phi is equal to e naught r phi e raised power j omega t minus beta z. That has applied at here. Whenever we apply at here, we got this minus j beta e phi, and minus minus cross, and similar for this er with respect to also dz, that is also minus j beta er is to be came out, negative sign is to be taken common, that's why there is a positive sign. Next dr component ez fell, so it is not there, so that is not taken, and another is the same value we have to be taken here, and on the this right side h is equal to hr plus h phi then hz. So we just in the next expression comparing the left hand side component with the right hand side component in the equation. So whenever we compare the each value of this minus j omega mu hr, j omega mu h phi, and minus j omega mu hz, These are obtained with the equal value of so the this right side that is equal to the equation of this r vector, phi vector, and z vector. So 9, 10, 11 these equations are obtained. Similar for another, if we take the value of this del cross h is equal to the value of minus d uh, d upon d dt, and the value of d is to be taken as epsilon e, and we got on that j omega epsilon er e phi and ez. These three components are came out with positive negative sign. Similar in the right hand side, we just have to take the del cross h and corresponding value of vector r phi z, that has to be added, and by cross multiplying and then putting the value of this h phi, which is the propagation of z component, that value is also taken, and we obtain these three equations 12, 13, and 14. Here in previous HR, H phi, HZ is representing the left side, with the expression in the another ER, E phi, EZ is to be represented. And on the right side, we use the component of E, which is EZ. E phi is to be accordingly value is to become after solving the del cross E as well as del cross H for this propagation. So now after that, for cylindrical waveguide, the basic equation that can be written as del square phi. That is the wave equation which we have basically find del cross E or del cross H is equal to a mu epsilon d square upon d dt square into mu. So this is the wave function. It may be a E or H. Now exactly if we have taken this del is basically a Laplacian component, and this Laplace operator may be a scalar Laplacian or a vector Laplacian, depending upon whether it is operated with the scalar or vector. So for del, the value is equal to d upon dr, d upon d phi, d upon dz. Whenever we take this del with some phi, then according to its vector, the value is to be merged out like the value of 1 upon r is the outside component, and r d upon d phi, that is came out, okay, and another is so the value del phi, then we taking again the divergence, mean to say that that is become del square phi, which is equal to like there is a again multiply with the d upon dr, d upon d phi, and d upon dz. But the equation of basic equation del phi, that is represent with d upon dr, d upon d phi, and d upon dz with its original part like 1 upon r, and r d phi upon dr, that is to be there. Another on the this side, we have 1 upon r square, d phi upon d phi, and at here d upon dz is to there. For the divergence, that will give you a second or this part, and that is become the sphere. This is also become the sphere. Further, we can write like this 1 upon r d upon dr. Whenever we taken this d square is I upon dr square is to be obtained for first value. Then if we take this dr upon dr, that is cross out, and we obtain 1 upon d xi upon dr. So this expression is basically u into v formula is to be applied at here in order to find the differentiation with respect to dr. So that is used. So this is the basic wave equation based on this xi component. Now, if we consider the field component to be a time harmonic, like xi is also equal to the e raised power j omega t, and whenever we take this with respect to a time derivative d xi upon dt, j omega is the component is to be came out with the same component is to be, that's why xi is to be there. Whenever we take the square, there is a j square omega square and same component j square is equal to -1. So uh, from this equation basically we can say that d square upon dt is equal to minus omega square. That expression is merged out from this formula. Next, if we apply into the this 20 equation, we obtain the right hand side is equal to omega square. Mu epsilon is already there, xi component. This equation is a partial differential equation, and it can be solved by using a method of separation variable. Now, in this equation, if all these three components are phi, z, all these are the independent, mean to say that the solution for that are this I is equal to say one of the component is r, which is depending upon this r vector, and another is the psi component which is also dependent upon this angle, and a third component is in the z direction. So signal is basically we know that propagate in z direction, and if we eliminate this omega t part, then in z that there is a e raised power minus j beta, z direction part is to be came, this part is to be there, and when we take the derivative of d psi upon dz, we got j beta, and when we take square, well, again derivative of this d square for xi upon dz square, that is become j square beta square psi, j square is equal to -1 and beta square psi is to be barred out. From this equation 24, this component d square upon dz square is also equal to the minus beta square component is obtained. Now we have consider, previously we have find for R and also find for Z. So for the fiber core, we have to fix the value of this R and Z. Now if we changing the angle, this phi only, and looking at the circular plane perpendicular to the z-axis, this means that phi is vary from 0 to 90, 180, then again 360. 2 pi variation for the cylindrical fiber is to be occur. So for that we can achieve this only when this component of xi phi with the component of g e j psi. We have taken v with which may be any integer, and from previous we know that d square upon dt square is equal to minus omega, that we have already found d square upon dz square is equal to minus beta, which we have already found from here. Whenever we take double derivative d square upon d phi, which is also equal to a finder. Now this expression we know the wave equations of expression. Now we apply all these value of these into this expression, but here we have taken d square upon d xi, d square xi upon d phi square. So that minus v that we have applied at here, that is 1 upon r square minus v square into xi, plus then there is a d square upon dz, that is minus beta square into xi. On the this side there is a mu and epsilon, and d square upon dt is omega square. So all these three values is applied in this expression, and we obtain this expression uh, for further. So this expression, whenever from right hand we just shift to the left hand side, and the negative sign is merged out to be a positive. Now the part of 1 upon r v square upon 1 upon r, that is the negative we have put here, minus beta square, that is the separate part, and omega square mu epsilon. So xi is the common component that is taken out. Now this important function, if we see omega square mu minus beta, we have considered it as a q square. Q square is equal to omega square mu epsilon minus beta square, that we have put at here. This expression will emerge out. So this expression, when we have to compare with the standard equations d square upon dr, now xi is basically taken as the common, and this expression where we have taken this rr component is also the common instead of that, and this is basically known as the Bessel equation, which is depending upon the parameter this v and q dash. Here v and q. V is always a positive number. Q may be a real, may be a imaginary, or may be a complex. So depending upon q, there are several solutions for this Bessel function. So physical understanding of this field distribution is required for proper solution. So main thing is that this Q factor that will march out different kind of solution for this step index fiber, depending upon the, so depending upon the condition we find the various solution. For traveling wave, beta is always real, we know that, whereas the mu and epsilon is always real and for losslessly. Now Q should be either a pure imaginary or a pure real. Q is matter. For pure real value of this Q, the solution of Bessel function and Newman function, that has to be there, like which we have put here instead of this xi, the function of RR, it's having a two solution. One is alpha 1 j v component of qr plus alpha 2 n new one function. This is the Bessel function basically. J Bessel function, the part of that r is to be included because in the r direction, and q having a real value or imaginary. Q value real have we have put here, and alpha 2 is equal to this Newman function with the v mode that has to be taken, and real function q in the order. So alpha 1 alpha 2, these are the arbitrary constant, v is the order, and qr is the argument function which we have taken. So from this, the Bessel function, if we see, which is this Bessel function, the component of this v, q and r, which is propagating here, having a fundamental j0, j1, j2, these are the functions. From the Newton functions, that may be a n0, n1, n2 along the direction. So this Bessel function with the v and x is always finite for all value of this x, whatever may be. And except j not x, which is 1 for all j, this Bessel function x are 0 for x is 0. we see that all function are 0, whatever only leaving this j naught. And Bessel function having a oscillatory behavior as in the x direction, whereas this Newton function is asymptotically divergence to minus alpha minus infinite goes to as x approaches to 0. And Newton function have a oscillatory behavior which is also a function of both having a oscillatory behavior which I represent. So for this guide, as the guide media is used for transmission, the mode is guided. When field is confined, it's to guide field decay monotonically outside the media, outside the code. With the graph which we have, field do not decay monotonically. Field is basically propagated inside the fiber. So this Newton function is infinite at center of the core. R is equal to 0. That is not possible. So that Newton function is not the part of that. So proper solution for inside the guide for real value of q is given in equation. We only consider this r is equal to alpha this Bessel function into a q form. Only Bessel function is to be considered. Now, for pure imaginary value of q, solution are Bessel function and Newman function. Previously, we have finded the solution for this purely real value of q. Now, for purely imaginary value of q, the solution of Bessel function, Newman function, that can be RR is equal to eta 1 this k v q upon j plus eta 2 I v q upon j. So eta 1 and eta 2 are the arbitrary constant, v is the order, and this q r upon j is the argument function, and the value of this kv and iv which we have represent are the modified Bessel function of first kind and second kind respectively. Now if we see this modified Bessel function of first kind, it is for this iv which is goes on increasing, and another is goes on increasing for this k. IV is monotonically goes on increasing for a function of x and reaches to infinite as x approaches to infinite, whereas kv is the monotonically decreasing function of x and reaches to 0 as x approaches to infinite. So as x approaches to infinite for this modified Bessel function of a second kind, and for guiding the media, fuel should be confined inside the guiding media core of the 5D, and it is decreasing monotonically outside the media, mean to say that cladding, otherwise it should be retained in the core of the. Now we have from this both function should have not the solution either iv cube or this second function upon j increases, r is increasing, so this should not be the solution for field in the cladding of the fiber. Now another is the first kind, this second kind kv qr upon j decreasing monotonically as r increases, so this should be the solution for the field in the cladding. So outside the guide media, we can write this anita 1 kv. This part is not included, not the part, and only anita 1 kv q upon r is the solution for outside the guide equation, that is represent 31. So the choice of solution is quite obvious that equation 30 is the solution for field inside the core of the fiber, and another if we are finding the outside the core, we having imaginary part. 32 is the solution field outside the code. Here analysis, we have put the condition that beta beta is there because omega square mu epsilon minus beta, that is it gives you a q value. Beta for inside and outside the core, that will give out the value inside the core, like when your diameter r is less than that of a, then in this q square is equal to 0, and in that case if that is 0, this means this beta square that is less than that of this omega square mu epsilon 1 inside the core. For the outside the core, inside the core for fiber, we have evaluated for outside the core of the fiber when the value of r is greater than a and q square is become less than 0. When that is 0 less than 0, and automatically beta square propagation part is greater than omega square mu epsilon 2. So if we have to write in term of propagation constant is bound by, then this omega under root mu epsilon 2 is less than beta beta, and beta is less than that of omega under root of mu epsilon 1, the boundary which we have represented. Or another way we can also represent by n1 and n1 and n2 for this. So propagation condition, that cutoff condition we can easily find for this. So by putting these conditions in 24, 26, 30 and 32, all these question in question number 23, then we have a final solution of this is xi1 for r, phi, z and time component is represented by a alpha. This jv is the Bessel function, ur e raised power jsi c minus jv phi minus j beta z plus j omega t for r is less than a. And another solution is phi to r comma phi z t, in which eta 1 in this modified Bessel function kv is to be taken, wr e raised power j v phi minus j beta z plus j omega t for r is greater than a. So q is equal to, here u is equal to basically under root of omega 2 mu epsilon 1 condition is to be there in this, and minus beta 2, and q is equal to j omega equal to beta 2 minus omega 2 mu under root the epsilon. So that condition is taken. Now for finding the solution for inside the core or outside the core from these previous two questions 34 and 35, which we have found for inside the core, r is less than ez1 and ez2, that is equal to a this jv ur is equal to ej v phi minus j beta z plus j omega t, whereas for h it is equal to another part, instead of a there is a b, and same component are to be there, there is a jv Bessel function for, and ur e raised power g vy minus j beta z plus j omega t. Outside the core of the fiber when r is greater than, now in this modified Bessel function is to be taken, and here ez2 is equal to for our r phi zt, like we can also write it here r phi z that is equal to C and D, otherwise all value are same. KV omega WR e to the power j v 5 minus j beta z plus j omega d. Similar for H component is pi. ABCD, these are the arbitrary constant where we can determine the boundary condition from them. And cutoff condition is at the point which a mode is no longer to bond in the core of the fiber, it is propagate in the clad of the fiber. Second condition is on beta. Beta can be deduced from the behavior of this Bessel function. Inside the core parameter u must be real, and accordingly we can represent in the form of propagation part that clearly divides that this beta component that is inside the core or outside the core, that easily defined. So the solution of a particular field we have to find from here, and if there is a need to change the alternate way of finding inside the core or outside the core, that field is to find, and the value of propagation that marked out whether the field is inside the core and outside the core, and boundary condition that has. In next we have to find modes of this step index fiber V number and mode field diameter. Thank you very much.